A quadratic function has the form y equals ax squared plus bx plus c, where a cannot equal 0. The variable a will be explained later. Graphs of quadratic functions are called parabolas. The point at which the parabola begins to turn is called the vertex. The vertex of a parabola is either the minimum or the maximum, depending on if it has a positive or negative a value. Both sides of a parabola are symmetrical about the axis of symmetry. This means that points on the graph are mirrored about the vertex. The zeros of a parabola are the points at which the x values are 0 on a graph. A parabola can have either 0, 1, or 2 zeros. A parabola will have 2 zeros if the vertex is negative, 1 if the vertex is on the x-axis, and none if the x value is greater than 0.
I'm going to tell you how all those variables you just learned about in the previous section actually impact the graph of the quadratic function. So here we have our basic quadratic function. It's just y equals x squared, and that's its graph. Now, if you change the a variable, say, which would be right here, it's just invisible, it's 1 for that one. If you change that to like 0.5, which is this one right here, you can't read it, but yeah, it actually horizontally stretches the graph, making it a wider graph, which, as you can see, it's a bit wider. You can also change a to 2, which would cause a vertical stretch of the graph, which makes it a bit narrower and makes the graph look like that. The last thing you can do with a is if you make a negative, which here it's -1, it actually flips the graph over and makes it negative, this is what that function would look like if a was -1. H controls the horizontal translations of the graph. So here we have your basic y equals x squared. So that's what that would look like. But here, h is -1, which you have to remember, in this equation it is x minus h. So h is -1, but it actually looks like it's positive. It's not. Don't be fooled. So the graph moves over -1, so 1 unit to the left, and then that's it. That's your horizontal translation. All right, next up is k. Now k controls the vertical translations of the graph. So one last time, we have your basic y equals x squared here. And then this right here is y equals x plus 1 squared. That's what this is. K is 1, so the graph is just shifted up 1 unit. And so the entire thing shifts up 1 unit, and that's what k does. Congratulations. You know quadratics.
Right, so in order to find the equation off of a graph, you use the vertex form, which is y equals a times x minus h quantity squared plus k. The vertex is usually found in this because of the h and the k values, which would be h and k. And even though this is subtraction, if the h is still positive, unless this would be a plus because the h would be negative. And so in this problem, you look at the graph and you see that at 1, 1 is where the vertex is. So that would be your h and k value. So your h would be 1, and your k would also be 1. So you can plug that into your vertex form. So it would be a times the quantity of x minus 1 squared plus 1. And then from there you go back to your graph and you look for another point in the graph. For example, 0, 3, which is the y-intercept. You plug those values in for the x and the y. So the y would be 3 equals a times 0 minus 1 squared plus 1. So you solve this out, so 3 equals a times -1 squared plus 1. That would be 3 equals a, since -1 squared is 1. And then a plus 1, 3 equals a plus 1. So you subtract 1 from both sides, so a equals 2. That gets you the equation y equals 2 x minus 1 squared plus 1. This is the equation in vertex form. And
This is problem 1 from review set 1C. The problem is, consider the quadratic function y equals 1/2 x minus 2 squared minus 4. Part A of the question is, state the equation of the axis of symmetry. The axis of symmetry is simply the h value, so you just have to look at the equation and see that the h value is 2, and then there you go. X equals 2 is your equation for the axis of symmetry. For part B, find the coordinates of the vertex. You've already gone halfway, because the coordinates of the vertex are simply h, comma, k. And we already found the h value, because that's 2. Then for the k value, you just read whatever the value is at the end of the equation right here. That's your k value. So the coordinates are 2, comma, negative 4. That's it for that. Then for part C of the problem, which is find the y-intercept, all you have to do for that is sub 0 in for x, because whenever you're at the y-axis, you have to be at x equals 0. So you just sub that in, and then you solve for y. So went there, then I subbed in x equals 0, then just worked my way through to get y equals negative 2. And the final part of this question is sketch the function. So I started by putting the vertex down right here, negative 2, negative 4. And then I graphed the y-intercept at negative 2. And knowing that the axis of symmetry means that whatever's on this side will be reflected on this side of the graph, I knew that there will be a point right there as well. To get these points, I simply just plugged in x equals 6 into the equation and solved for what the y value would be, which is 4. So then I solved there, and then I mirrored it there. And that was enough information to sketch the graph.